Now, in previous video, we've covered one of the more important functions that we're going to look at higher level mathematics. We covered the exponential function. So that was our y equals e to the x, or y equals a to the power of x, where instead of having our unknown value as the base number, we've actually got our unknown value as the power of a. What we're going to look at in this video is another key function that we're going to need to work with, and that's something called a logarithm. Now, think about what we've done before. Previously, we've looked at if we had the question p to the power of 6 equals 512, how do we find what the value of p is? Well, we know that if we have something like that, all we have to do to find out what p is take the 6th root of 512. So work it back that way using our calculator. In this case, the power is the known part and the unknown part is the base number. Let's imagine we flip that though. Let's imagine I say to you, right, the question I'm going to ask you is 6 to the power of x equals 512. Well, what I've done here is I've taken the base number and I've given you the base number. However, I don't know the power. I don't know the index part of that. So what this question's asking you is what power of 6 would give me an answer of 512. So again, in this one, I do want to know what x is. That's still the unknown part. It's just the power. Now, this is when we introduce the idea of a logarithm. So we can note this and write it down using the notation that x equals log with a 6 there of 512. Now, what this literally means and what this literally could be read as is x equals log to the base 6 of 512. Now, in this sort of question here, that we have it in that format, so let's imagine it's the format log of a to the b, what this literally is telling you is the power of a, which gives b. Yeah, so what power of a gives b? And that's literally what the question was asking us. So what power of 6 gives me the number 512? So when we rearranged it, log to the base 6 of 512 literally meant what power of 6 gives me the number 512. And this is the idea of a logarithmic function. Now, they can always be written in a specific form, which is this. F of x equals log to the base a of x. So again, it's the same general idea. What power of a gives us this number x here. Now, there is a key thing you have to always remember for logs involving these kind of values, and that is quite simply that a and x are always strictly bigger than 0. You cannot have a negative number going in here. So you can't have, for example, log to the negative 1 of x. That just doesn't work. You're not able to do that. And similarly, you're not able to have log to the base a of negative 2. We can't have that sort of question going in there. They just don't work. Now, we talked previously about exponentials and what they were. Well, there's a key relationship that exists between logarithms and exponentials, and that's the fact that they're the inverse of each other. We're able to say that if we have a function, let's say it's y equals log to the base a of x, there exists a relationship that says x equals a to the power of y. We're able to invert these functions and relationships to each other and express them that way. Now, that's a key property of logarithms, because another thing that allows us to do is figure out what the graph of a logarithm looks like. Now, when we covered exponentials, this was what we said our graph of an exponential looked like. It was always strictly bigger than 0 in the y direction, always cut through 0, 1, always went to the point 1, a, every single time, no matter what. Well, we know that logarithms are the inverse of that, so all we have to do to get the graph of it is flip the function and reflect it in the line y equals x. So our logarithmic function looks like that. Again, same sort of properties here. In this direction, it gets closer and closer to the y-axis, but it will never ever cross it, so you'll never get a negative value of y. Where it cuts the x-axis is this point reflected over, so it's at 1. And this one here, when we're cutting this point 1, a for the exponential, the point we cut here in this case is a, 1. And that there is the general graph y equals log to the base a of x. That's what our general graph looks like for any logarithmic function that is out there. So let's use this to show you how this could be represented for a logarithmic function. So let's imagine I've got my blank set of axes here, and I want to plot the function y equals log to the base a of x, but in this case what I'm going to tell you is that instead of a, I'm going to get y equals log to the base 6 of x. So I'm going to give you a value for a. Now we know the function generally looks the same way, so it comes up this way, cuts through the x-axis, and then goes off to infinity in this direction. The x-axis cut, unless we perform some sort of graph transformation on the logarithm, doesn't change. That's still going to be 1. And we know it cuts a point here where it was a comma 1, so we know our y value doesn't change. But our x value depends on what the value of a was, and what I'm going to do for this new function is I'm going to tell you the value of a is 6, so it's going to cut at the point 6 comma 1. And that there is my graph y equals log to the base 6 of x. We're able to use that general property to sketch the curve of a logarithm. It always looks the same. These are the two key things you have to mark on every single time you do it. Now, logarithms generally let us write a few things as well in terms of logarithmic form and evaluate things. So for example, if I had 5 to the power of 3 equals 125, I know 5 cubed is 125. It's part of our basic mathematics. Imagine I wanted to write this in logarithmic form. Now remember, something that's written as y equals log to the base a of x is wanting to know what the power of a gives me x. So in this case, writing this in logarithmic form, I use my base here and I want to know what power of 5 gives me 125 in logarithmic form. So the way I'm able to modify this and write it is to say that 3 equals log to the base 5 of 125. And I know this is true. What power of 5 gives me 125? Well, 5 to the power of 3 is, so I know that that's where the y part there on the left-hand side comes from. 3 equals log to the base 5 of 125. Now that's writing something in logarithmic form. Imagine I asked you to say, if I've got log to the base 4 of 16, and I want to evaluate it. So I want to know what the answer to that is and what it actually means. Well, log to the base something of this means what power of the base gives you that. So what this is asking you is what power of 4 equals 16, i.e. 4 to the power of something equals 16. What is that power? Well, we all know that 4 squared is equal to 16. So what I'm able to then say is therefore log to the base 4 of 16, so the power of 4 that gives me 16, is equal to 2. Thinking of it in terms of this actually makes it a lot more easy to understand. It makes it a lot more understandable, relatable, and actually thinking back to our basic maths that we had before, it's all about learning the powers. If you know the powers of numbers, logarithms can actually be quite a straightforward thing. Now, this video was designed as an introduction as to what a logarithm actually is. It's something that could be quite confusing for a lot of people. There's a lot of things that we're going to be able to do with them, including laws of logarithms and various other properties to do with them, which we'll cover in later videos.